So we've made all the major cuts to our rotor. It's time to come back and put the hole through the middle for the spindle. We will start that process off with a center drill, get a little nub on there to start the drill. Our call out is 1875 ream. That means this is a precision fit. A ream is a little bit different than a drill bit. It doesn't have a spiral flute to it. They're actually straight sides, and they're very precision. In order to get this to work, however, we will need to drill our hole one size smaller than our ream and allow the ream to do the last of the work and cut that out to the final 1875 dimension on there. In order to do that, we look over at this chart, and I'm going to just pick the camera up and show you guys here. Hope you can see this on the wall. I have a couple of these up around the shop. They're extremely handy. Earlier there was a question, I think during one of the lectures, about what is a number 8 screw, a number 6 screw, 10, 1024, 1032. These are common call-outs. Up to 12. Usually over the size of 12, you start going into fractional sizes, quarter 20. So the diameter, major diameter of your screw, and then the threads per inch. It's a similar setup in the metric side, so you've got an M6 would be at 6 millimeter, and then that's 1 millimeter, was that 1 millimeter per centimeter, I guess, is the actual thing. So they give you a decimal equivalence on that. So I refer to this chart all the time. I'm looking for a 3/16 hole, 1875, and I know I need the drill bit. Whatever drill bit is manufactured, the next size smaller, and this has got every size of drill bit that's manufactured, at least as far as I know in standard manufacturing processes. So we'd be looking for a number 13 size drill bit. That'll put us at 1850 and will allow our ream to do that last 2.5 thousandths cut and get a nice precision fit. That's got to be really, really close in tolerance to the 3/16 spindle shaft that we put in there, because the knurling process we'll do right at the end for final assembly only raises the metal, 1/1000, 2/1000ths of an inch, slightly more if you really kind of hog on it, but you get a couple of thousandths. So that will basically allow us to have a tight press fit, and as we press the spindle into the rotor, it will actually slightly deform the knurling process that we put in there and make a nice permanent connection for us. So all right, let's go ahead and drill that out. Okay, I've laid my tools out here, well, except for my center drill. So you've seen these before. I'll do this on this camera here. So here's our center drill. Nice little point there, and that's just going to allow us to start our drill. And I'm going to roll this up as close as I can here. Lock that off. See, I'm working a very small diameters. I am in steel, but so I'm going to go ahead and work in the high range. Forward speed, of course. And I'm going to put just a very light coat of oil on the tip of our bit there. I'm going to dial this in, and we're just going to touch off. Nice and easy like that. Just a little starting point. Okay, this is our number 13 drill bit here. These are shorter than the normal drill bit that you might find at a regular hardware store. These are called a jobber length. We mentioned that that fluting and a long piece of material like this, there's a lot of chance for flex and movement in there. So a shorter drill bit allows us to have a more rigid setup. Should give us a little bit more accurate cut. And it's going to be especially important when we do the reaming process, but when we drill this out, we really don't want to dwell inside the hole for any period of time, because if our alignment is off at all, the drill bit itself will actually start to ream out the hole that we've got, and we don't want to oversize that hole, because then we won't be able to get a tight fit on our spindle. So again, I'm going to add a little bit of oil to our drill bit, touch on the face here. And you know what, this is kind of a fast RPM. We're up to, I said, a number 13, slightly high through 16. So I'm going to switch this into low gear. But we're going to run this up to maybe about 400 RPM, 350. So slide that up, lock off our tailstock, and bring in our ram. And we do still want to do our peck drilling as soon as we see that chips are no longer coming out. You see a little bit of movement in that drill bit there. A little bit of wobble. I can continue to move inward as long as I see chips coming out. And I just felt that let go on the backside. So we're going to back that out. And we're done. So back this up a little bit. Clear up our chips. Okay, so now I'm going to insert the ream. And I'll show you this on camera here. Let's see if you guys can see that. So this is our ream. Sometimes I tell you actually on the ream what size drill bit that you need to use for it, but in general it's the next smallest size that you can find on there. I can't even read that, it just says 0.1875 on there. So what we're going to do is we're going to bring this in, well oiled at a nice slow RPM. We'll bring it in right until we make it all the way through, stop the machine, and then back out. Again, this one we really don't want to spend any time dwelling in that hole at all. We don't want to open this hole up any larger than the 0.1875 that we're trying to get to. So bring my tailstock back up. I'll lock that off. And I'll put my lathe down to the slowest speed. I'm going to put a real heavy coat of oil on that. Try to get a little bit up into the hole there if I can. There we go. The ream is a very hard tool, very brittle. So if we get off at all on this, they're very easy to break. So I'm going to bring this up here. And I know that the total thickness of my part is 3/8 of an inch, so I'm going to kind of look at the ram here. Make sure nothing catches. I'm going to go nice and slow, nice and easy, continuing in, nice and easy. Well, I know I've got a full 3/8 of an inch in there. All right, that's good. And then we'll shut down, straight out, just like that. All right, we can move our whole assembly back here, get our oil and chips off of there. So that should be our finished spindle. Now, I feel a very slight little burr on that, so we'll use a reaming tool, or excuse me, a deburring tool, and clean that out. All right, so you can see our spindle there, I'm sorry, our rotor, hole all the way through. And yeah, and I feel a little burr on the backside of that one as well, so we're going to go ahead and clean that up. All right, here's our little deburring tool. Just run that around in the hole a little bit. And we're taking that off. That's not enough to change the size of our hole because all we're doing is touching right off at the edge there. Same thing on that one. Steel's a little harder than the aluminum, takes a little longer to clean that off. I still feel a real light little edge on there. There we go, that feels pretty good. All right. So here's our spindle that we made previously. This is going to need to fit inside of there. And it should just barely fit. Yeah, you can see I can just sort of barely squiggle that through there. That means those are both pretty close to 1.875. So that'll make us for a nice perfect press fit, just like that. So next step we've got to do, we'll line this up in our frame, mark off where the knurling needs to be, knurl that in the lathe. We'll go back over to our collet, and then the last thing we'll do is punch a little hole in the center of that, put the string on for our rotor. So let's go do that. Now that we've finished our rotor, we're going to go ahead and use that in our frame to align on our spindle here and mark off where we need to knurl. And then we'll also stop by at the milling machine and go ahead and put this little 3/32 hole through there. All right, we have our rotor, we have our spindle, we have the two little brass bearing support pieces and a couple of lock nuts for those, and our frame. So let's go ahead and assemble that. slide these on here. Hopefully all these threads work okay. It's all right. So just far enough in there. Now what I'm going to do is, let's go ahead and put that little lock nut on there too. Maybe. There we go. Okay, so I'm going to slide. So there's the top of our frame, 3-hole side up. Our rotor goes this way up. So it just slides on there. And I'm going to put that in our frame. About like so. It's a close fit. All right, get that one up in there. Okay, and I just want to center the threads until I get a little bit of tension on that spindle in the middle there. Okay, so about even amount of threads showing out of either side. Our spindle, therefore, is roughly centered in our frame. Our rotor can slide back just barely on that spindle, so I'm going to center the rotor within the frame. Use our trusty little Sharpie here, and just mark off on both sides of our rotor there. And now we know where to do the knurling. So let's go ahead and disassemble this. And we will, actually before we put the knurling on there, we're going to go ahead and put that 3/32 hole on there. We want the spindle piece itself to lay down as flat as possible when we do the milling. So if we've put a raised knurl on there, it won't necessarily sit flat in our V-blocks for doing that last hole through there. All right, so let's go over to the milling machine. All right, so we're going to use a little V-block in here to lay our part in, like so, with this little clamp to hold it in place, and then we can put this hole set up into our vise for our milling machine. We'll use our edge finder to touch off from the edge here, and then we'll come back, edge find the center of our part, edge find off the edge of this side here, I think it's 1/2 inch or so. Then we'll center drill and drill the part there. Okay, so we need 3/8. Okay, 3/8 collet. Okay. All right, so let's get ourselves close to our part here. And hopefully our spindle won't hit this guy here. We'll find out in a second here. That's pretty good. All right. So if we wanted to, we could probably raise this up on some parallel bars. In fact, what we're going to do is raise this up on a couple of parallel bars. It'll make it easier for the camera to see what's going on here. So let's just grab some parallel bars. I think we introduced these before. I'm going to sit in here. Make sure it's nice and clean. There we go. And now we'll set our fixture up here on top. And this is just going to make it easier for the camera to see what's going on here. So, all right, so I'm going to bring this down. What I'm going to do first is touch off on the front and back of that, essentially measure the width of our part, take half of that, just the center line. Then we'll come over and we'll touch off on this edge here, which is the very tip of our edge finder, and then move over. Let me grab my plans here. So we need to put that 3/32 hole 1/2 inch from the tip. Yeah, in fact, what we'll do is we'll just go off the tip. I was going to use this shoulder right here and go 1/4 inch down, but we'll just go off the tip. It'll be easier to locate that. All right, so I'm going to move to the back side of our part, make sure our edge finder is off. Center a little bit there, tighten our quill down. All right, so I'm at about 1100 high range. Slow our edge finder down to around 500 or 600 or so. Okay, get our digital readout ready. All right, let's make sure we're well within our part here. So we're just gonna go until we kick off. All right, there is our first Y0. Bring this up, move it over, back down, and we're going to come back. Our edge finder goes a little smoother, and then right about there. Over. So turn this off for a sec. Roughly 380, so we're going to go to about 190 as our midpoint. So we'll raise our quill. We'll move this back to 0.190. All right, and then we're going to lock off our Y direction. Okay, so we can no longer move in this direction here. We're centered over our part this way. You see that on the camera over there, which should be nice and centered. Now we're going to work in our X direction. Okay, same thing. We'll bring our quill down and touch off on the tip of our part there. I've never tried this on a point before. I assume it'll work the same way. There, we're smooth and just off. Okay, so I'm going to reset our X. I'm going to raise my quill, and I'm going to move the 0.5 over that the drawings call for, the 1/2 inch, plus the 0.1 radius of our edge finder. So we're going to go over a total of 0.6. 3, 4, 5. 0.60, and I'm going to go ahead and lock off the table now. 0.601, I guess we can try to make up for that. There we go. All right, machine off. We're going to go ahead and now switch for a center drill and then a drill bit. And I think we're going to have to lower our table in order to do that. Okay, I need a hammer. Instead of a hammer, sometimes I use a soft copper bar. Do the same thing. Tap out our part. And we'll take our collet out. Okay, we have a 1/2 inch collet for our drill chuck. I'm going to put that up into there. Make sure we got a hold of that. And I don't think there's any way that's going to fit up in there, so lower our table. All right, that should get us there. All right. Okay, a center drill. All right, we have our center drill. And we need a chuck key. All right. So everything's nice and aligned for us. We'll just bring this on. And looks pretty good. Just going to very gently touch off on that. A little bit of flex on the end of that piece. We could have moved it over quite a bit actually in this case. So, all right, so what we've done, you can see that in the video there. We've just made a little dimple on the top there. Ready for the drill bit. All right, this nice tiny little guy here. And I'm going to chuck up on that right up to just above where the flutes begin. And the shorter we keep those tool bits, the less vibration, less movement we'll have in there. I'm going to use a tiny bit of oil. I'll put a little drop right here. We'll brush some on our bit. And watch it all go flying off when I start our tool up. And nice and gentle. It's a real trick trying to drill onto a round shaft, especially a small diameter round shaft. If you can't line it up as carefully as this, then you're bound to get the drill bit to sort of run off the side of your part. The advantage of a milling machine like this is you get that really, really good accuracy to be right on top of that round shaft. And also everything is nice and rigid. And if I hadn't used that center point center drill to start the little dimple for this drill, it's entirely possible that with the flexibility of the drill bit itself, it would have just suddenly skipped off to one side or the other and probably broken the drill bit. So I'm going with a real light pressure on this thing here. Adding a little bit of oil as we go. There we go. Nice and clean. Okay, we can release our part here. And we've got some burrs on there. So real minor little burr on there. I'm just going to use a light piece of sandpaper. Just kind of clean that up. That's pretty good. Okay, so we have our hole in there. Hopefully you can see that on this camera a little better. All right, so there's our spindle with our 3/32 hole, nice and centered on the part there. And now we'll go over and we'll knurl. I think our rotor is 3/8 of an inch, and I believe our knurling tool is pretty close to about 3/8 of an inch. So we're going to just put that tool on there, clamp onto here, and put that knurl on there. So let's go over to the lathe and do that. Okay, over at the lathe here, we've got our spindle, our little hole drilled in the end, and we're looking to knurl the center between these two spots we marked off with our Sharpie. So I'm going to put this guy into our spindle, tighten that down, and we're going to grab our knurling tool. So this is a completely different kind of tool than we've used before. This is a forming tool rather than a cutting tool. And I don't know how well you're able to see on the camera here. I'm going to try to get behind here. So this two very hard little wheels here that have these horizontal lines. There are different types of knurls. There's crosshatch knurls, there's straight knurls. For this sort of press-in operation, a straight knurl probably makes more sense. Otherwise what you'd have is one set of jaws would have a teeth going diagonally this way and another one teeth going diagonally this way, and you'd get a crosshatch pattern of knurling. You've probably seen that on handles for things, anytime you need to improve the grip of something. In fact, usually when you look around on some of the machine tools in the shop, you'll find knurled handles and so forth. So this tool is going to mount onto our tool post. It's going to slide over our part, and we can kind of control the amount of pinch on the back side of that. What I tend to do is bring this in so that the space between these is just slightly smaller than our part that we're working on, and we're going to do this kind of all by eyeball. I'll bring it in there, and then we'll use the cross slide to press this into our piece, and the pressure between being pressed in and sort of being wedged in between these two wheels here will cause that, that raised metal to be formed. As our part turns in there like that, these wheels will turn like this. So hopefully this all makes sense. So let's lay this into our tool rest here. So I gave myself enough room to get everything put in. Actually, we're going to move it around to this side. Lock that in, and we need to rotate our tool post. It's important for our knurling tool to be basically perfectly horizontal with the part that we're working on. Give myself a little bit of room here. Okay. So I'll kind of do this by eye. Right about there. Oop. Moved a little bit on me when I was tightening it. All right, there we go. Snug that down. And we do want to make sure these are fairly snug. So this is a forming process. There's actually quite a bit of pressure involved with this. Let me make sure I can get in close enough to my part here. Okay. So I have a limit to how far I can bring the carriage towards the spindle this direction, and that right there is the limit. So in order to make up that last little bit of gap there, I want the part to be as close to our collet as we possibly can get it. That will make sure that we have less opportunity to cause any flex in that. I'm going to have to pull the part out of the collet just a little bit. Make sure that we clear that. There we go. So I need to get over on top of this thing here so I can see what's going on. Okay, there's a kind of a eye. I want to take up the slack in this tool here. Yeah, right about there. Okay, so now I'm going to bring down the width of these jaws a little bit, and I'm going to kind of do that as I go. We want to definitely be in our low range. Pretty much all forming operations are going to be a low range, low speed. And we definitely want to use a little bit of oil on this. Build up some chips in here, and we want to keep those chips flushing out of these little wheels. It makes for a nicer knurl. If you don't get those chips out of there, they kind of get pressed back into the metal. All right, so forward direction, it's about 100 RPMs, the slowest this lathe will go. I'm going to bring the crossfeed in until it touches on both wheels. I'm going to back up, and so this is kind of a eyeball it sort of thing. So let's stop there for a second. So that was a first press in, and you can see I've got a little bit more depth, I guess, on this side than I did on this side. We're also not quite to our line, so I'm going to move this forward just a little bit, and we're going to adjust the angle of our tool just a little bit to get a more even knurl on there. So just a tap this over just a couple of degrees maybe. Snug that back down. And I'm going to close up the jaws just a smidge, maybe a quarter turn or so on that adjustment knob. Make sure we got some good oil on there. And you kind of come back in gently with this. The last knurl should catch the one you're doing now, and we'll kind of keep all the grooves we're making on top of each other. So I'm just pressing this in. Okay, let's take a look at our knurl, and then we should be able to feel. You can feel with your fingernail a few thousandths. I'm not really feeling an erased pattern there yet, so we're going to swing our tool a little bit further. Tighten our clamp down a little bit. more oil. All right, you probably can't hear this come through, but I can actually hear there's an actual vibration coming through the machine. At that point, I know that I'm getting a good bite on my knurl. I can also feel more pressure and resistance in the knob down here. And so I'll press on that. The machine makes kind of a responding vibration. That vibration kind of goes down a little bit as the knurls are formed. Now let's take a look here. Yeah, there's a much more aggressive knurl on there. Feel just maybe 1/1000th or so. So we're gonna go just a hair further. We don't want our rotor coming off of our spindle. All right, making that vibrating sound. That should be good. There we go. We've got our nice good knurl on there now. And we can confirm that by grabbing our rotor. And hopefully we got the little burr off the hole that we made. Yeah. So now it comes right up to that knurl. I can't quite press that on by hand, so we'll use, made a little tool that we'll use to press that on there. So let's grab that. So all I did is just take a piece of aluminum pipe, make sure there's nice and squared, faced off at either end, and then we can actually, well, everything's in the lathe, everything's nice and lined up. We have a nice square face on our ram up here. We're going to use that to press our rotor on there. We should, I want to turn our rotor around. So let's pull our spindle out. And I'm going to stop the knurling right about, I'm going to put the part just outside of the knurling there, and that will allow us to press our spindle right on until it stops at the collet. So let's run this forward a little bit here. Whacked the camera there. All right, one problem with doing this sort of thing here. All right, I gotta tighten off the ram here without hitting the camera. Okay, so now we're gonna just run this up against here. And just like that. Okay, let's take a look. All right, so there's our rotor on our spindle. Let's go see how it fits in the frame. All right, so now we have our rotor pressed onto our spindle. We have the hole in there. Everything's nice and tapered off. Let's go ahead and see how this fits into our frame. These little adjustments allow us to make up for a little bit of error if we don't have that quite centered. So let's see how we're looking. Get those right inside there. So I want to make sure to bring the rotor up so it's not touching the frame. That's pretty good about there. I'll lock that guy off. And then the top one, so then the top bearing will come down to just barely any tension on top there. We can feel if there's any play in there. Just nice and snug. So there we are, just about done. Let's give it a little test spin there. Reasonable. We've got a little bit of wobble in there, not too bad. Last step will be to make the metal ring that goes around the outside, and we'll do that next.